Hi, this is Hai Xiaowang, and today we're going to talk about the lowest common ancestors of a binary tree. And given the two nodes of P and Q, and also the root node of the binary tree, we're supposed to return the lowest common ancestors of the binary tree. Of here, um, given the binary tree, and the P is equal to 5, which is this node, and Q is equal to 1, which is this node. The lowest ancestor is 3, and we'll just go quick questions. Yeah, this is a little bit special, and the P is 5, which is this node, and the Q is 4, which is this node. So the lowest ancestors of these two nodes is actually the P itself, which is 5. So actually there are only uh, several cases which we can just draw in a plot. The first plot is that this is P and this is Q. So it's intuitive to think that this is their lowest common ancestors. And actually, the second case is that this is P or Q. If this is P, and this might be the Q, and this is a little bit special that we should consider. So my idea is that for every when we take the root node, we first check whether it's equal to P and or equal to Q. If it's one of the case, we just use a variable st to denote whether they are in one of the cases. So we will make the st to be 1, and if not, we will make the st to be 0. And then just to call the recursion functions and to try to do the recursion on the left subtree and also the right subtrees. If the left subtrees has the P or Q, the left we will assign the values that returned by the recursion functions to the left. And if the P or Q is in the left subtree, it will return 1, and if not, we will return 0. And this is similar for the right subtrees, also equal to 1 or 0. And if the for current node, if the st plus left plus right that is equal to 2, which means that the subtree that start from the current node has the 2 P and Q, so that will be our answer. We just store it in a global variable, and just after the DFS functions, we can just return it. So that's the code. In our node, this is the base case, which is return 0, and let's see. If the node is equal to P or node equal to Q, the st should be 1, else st should be 0, and we just do the recursion part on the left subtree and also the right subtree. If st plus left plus right is equal to Q, which means that there will be the result. We just store it into our global variables, and we just return whether one of the three cases that contains P or Q. So that will be st or left or right. think this that is works. Yeah, it seems it works. Yeah, you may feel confused why when the st plus left plus right is equal to 2 the node that will be the answer. We just explain if the if this is a tree and this is a p node and this is a q value a q node, and if we just if now we are here, which is a root node, and so the current node is not equal to p and it's not equal to q, so the st will be 0. And when we do the recursion part on the left subtree, it will return 0 2 because p and q is not in the left subtree. And when we do the recursion on the right side of the subtree, it actually will not return the 2 but just return 1 because here we just return st or left or right. So if the two so for this of the cases it contains p and q, but it will only return 1. So for the note here, the st plus left plus right is just equal to 1, which is not satisfies the requirement. So we'll just continue to DFS and go right there. And for this kind of node, that when we do the recursion part on the left subtree, it will return 1. I just write L denotes for left. And when we DFS the right subtree, and it will continue DFS and it will return right to be 1. And we found that L plus left plus right plus st that is equal to 2, and that will be the answer, and it's the lowest common ancestors, which is our answer. We'll just return it. Yeah, that's explanations about for these problems. Thanks for watching.